Okay, in this video, we're going to do hexadecimal to decimal conversions, but we're going to go through binary. So we're going to convert it to another numbering system first, and then go from that numbering system to decimal. This is a trick a lot of technicians have used in the past because they haven't had electronic devices, and they know one operating or one numbering system very well. They'll go to that numbering system, and it's easy to convert over. So just give you another trick to do this. We've shown you how to do hexadecimal conversions before. Might use a calculator. This one might not need it. We'll see what's there. You'll notice that I have a chart over here on the left hand side. It has hex numbers on the left and their binary equivalents. Usually when we put a chart on the left hand side, we're going to use that. So when you draw this chart, make sure it's right. Make sure you don't have any errors in there, because that's not going to help you out. You're not going to get the right answers until you're there. So let's pick a hex number as an example to start. In this case, let's do 1, 3F in hex. Sometimes some of the examples I pick, I'm not really happy. They might be a little bit harder, but a lot of times I pick them to prove a point. So if you remember our hex to binary conversions, we just do groups, right? This hex digit is going to yield 4 binary values. This one is going to yield 4 also. I can pull them right out of the chart over there. That's why I put the chart there, but most of these I know by memory. Okay, that gets me a binary number. Make sure you do it right, because if you go through another numbering system, you get this wrong, it's going to lead to an error in the final answer until you're there. So if you got that right, you're there. Now, how did I know to do this? Just experience. I went with what I knew were the easier conversions or things that I could do in my head without going somewhere. That's why I picked this method. So now I got to go from binary to decimal, and we've done that before too. We know this is the 1, the 2, the 4, the 8, right? And over here, 16, 32, 64, 128, and this one is the 256 position. Now 512, 1024, and 2048. I don't need those because I don't have any ones up there. So now I just pick the positions where I have a 1. It's a 256 and what, 32. So 256 plus 32. Got to do additions, right? 8, 8, 288. Looks good to me. Plus 16, that's the next place that I have a 1. 14, carry the 1. 8, 9, 10, 0, carry the 1. That's 304. Right? And it looks to me like all 3 of these, or I'm sorry, all 4 of these are a 1. So I know that's 15. So I'm going to take a shortcut rather than adding 8, 4, 2, and 1, and I'm just going to add 15 to this. Right? And I end up with a result of 319, and that's a decimal number. And I started with a hex number, went to binary, and got a decimal value because I thought it was easier. Some people might think that's a lot of writing. I'll have to write something wrong. You got to pick what you do the best. Normally I would take this and convert it back to hexadecimal through binary, not looking at what I wrote down just to make sure I checked the answer. But prior to doing this, I put it in a calculator and did the conversion, and I know that answer is right. So against my better judgment, let's erase that, and let's do something a little bit more involved to make sure that we got this procedure down. We should, right? Because we didn't introduce any new procedures. We are using procedures we already knew. And that's there. Sometimes teaching students, I'm going to find that can be confusing. But for the most part, it's exercising your abilities to follow the procedures through without making errors. Sometimes people say, nah, it's just confusing me. So 85FC this time. So C is 1, 1, 0, 0. I'm going to try and space these out a little bit better so when I write it. So F is next, and that's 1, 1, 1, 1. And 5 is 0, 1, 0, 1. By the way, if this would have been a 0, I still have to put 4 zeros here. Remember, I have to hold the values of the position, the weighting of the position, so I can't get rid of any zeros. I've seen students do that for some reason. So I got my binary number. If I was careful, just reading it from a chart, made sure the chart was right, that shouldn't be too hard. So now powers of 2. 1, 2, 4, 8. And I'm going to write sideways. 16, 32, 64, 128. 256, right? I think I have powers of 2 or multiplication by 2 either memorized, or I can do it pretty good. That's 1024. This is 2048. This is 4096. That's that first 0. And now things get a little tough for me, right? So let me take my calculator and do 4096 times 2. And I probably could have done that for memorization. I just want to make it feel good. That if you have to take your calculator and take that times 2, and 16,384, and I'm getting a little sloppy there, and then take that times 2, and that is 32,768. Now, it's a little sloppy, but I think we can do it. 32,768. That's the first place we have a 1. And then I go the whole way down here. So 1,024 is my addition. Once again, this seems a little tedious. If you get the process down with easier numbers, doing bigger numbers, just a little bit more of a challenge. The procedures don't get any harder. So what? 8 and 4 is 12. 6, 2, and 1 is 9. There's a 7, 3, and a 3. If I did that right, we're okay. So we got that 1 at 1,024. Here's 1 at 256. So you got to be decent in addition. If it isn't, you got to go get your calculator. So 8 and 4 carry the 1. 7, 8, 9, 10, 0 carry the 1. That's a 4, and that's a 3. And I think I did that okay. That took care of the 256. Now I come down here, and wow, look at all those 1s I lined up. I got to do 128. Now I'm bound to make an error, right? 6 carry the 1. 6, 7, that's a 1, a 4, and a 3. 64. I'm going to run out of room. I've been known to do that too. 13, that's a 14. 4 carry the 1. That's a 2, and a 4, and a 3. Okay, we're getting close to the end here. Make sure that you're only pulling numbers that you haven't added before. So plus 32 is the next one, right? And that one's pretty easy. 34 to 72. So I'm going to write that up here because I'm running out of space. 34,272 plus the next one is a 16. Once again, tedious procedure, isn't it? 34,288. And then now I'm going to just combine. And 8 plus 4, I know I have to add those two. That's 12, right? I'm going to add 12 to that. So 0 carry the 1, 0 carry the 1. This is a 3, and 34. And guess what? I did the addition right. We got our final answer. I've already converted that on a calculator and came up with the right thing. So once again, bigger numbers, go get a calculator, use your resources, but you definitely should be able to work smaller numbers without error. So this procedure is a little more involved, especially with bigger numbers, but using procedures that you've done before. So hope that helps. We'll see you in the future.